Hi there, this is Mohammed Aqeeb, and this is a demo for the topic which I have chosen, and that is rate of reaction, a comprehensive overview by me, Mohammed Aqeeb. So, we are gonna go over this topic for today's demo. So, let's get started now. So, first of all, when we talk about rate of reactions, let's see the real world application first. So, whenever we have a banana, okay, and if we refrigerate it, so the process of ripening gets stopped. And if we do not refrigerate the banana, it gets ripened, and the black spots come on it and it gets ripened, it becomes sweet, and the color of the peel, color of the skin becomes yellow. Okay. So what exactly happens when we refrigerate a banana? So the enzymatic reactions inside the banana gets stopped at low temperature. Okay. So if the banana is not ripe and we put it in the refrigerator, the enzymatic reactions are not going to take place, and the enzymatic reactions, since are not taking place, the banana does not get ripe. Okay. But in the opposite case, if we keep it at the room temperature, the enzymatic reactions are going to take place and the banana is going to ripe. Okay. So this is the basically uh, temperature control regarding the enzymatic reactions, and that is very commonly seen in our day-to-day life. So, yep, that is exactly what I said, that the refrigeration slows down the enzymatic reactions, and freezing food nearly stops most chemical reactions, which is why frozen foods can last months. Okay, since the enzymatic reactions are not taking place, are no longer taking place, the process of ripening gets stopped and their shelf life increases. Okay, so let's see another case of rate of reaction. Okay, let's see. So this is a reaction called as elephant's toothpaste, and you can see over here that how fast did the reaction take place over here. So this is basically one of those fast reactions. Okay, that, and we can call it as the reaction having very high rate. Okay, so our enzymatic reactions were a bit slow because it takes place over a duration of few days, but this reaction took place over a duration of few seconds. So this reaction can be called as a reaction having a high rate of reaction. All right, so what exactly is reaction rate? Now we are getting a bit of idea about it, so let's talk about that now. Okay. So the rate of reaction is basically the change in the concentration of reactants or products per unit time. That means that how much amount of concentration is getting changed in a given time duration. Okay. I will show this. I will show a graph for this as well. Just give me a second over here. So what exactly is rate of reaction and how do we express it? So the rate of reaction is expressed by delta concentration divided by delta time. Delta is basically representing the change in the concentration. So the example for this is moles per liter per second. That is, how can we represent it in terms of units? So mole per liter per second. So mole per liter is basically the concentration. The unit of the concentration is mole per liter, and per time is the second. So the times unit is second. Okay. So this is how we express it. So now let's talk about that, the change in the concentration with respect to time through a graph over here. Okay. So we are going to see the rate of reaction with respect to reactants first. So over here we see a graph. And may I ask you why the graph is going down like this? why it is not like this, or not, why not like this? Okay, so the reason for that is basically, since it is a reaction, I'm sorry, since it is a reactant, okay, and the reactant is going to get consumed when the reaction starts, right? So since it is a concentration of reactant versus time, so as the time passes, the concentration of reactant is going to decrease over time. Okay, so that is why we are getting this graph which is going down over here like this. Okay, and let's see what is delta R divided by delta T over here. So what they have done is the they have taken two instances. First one is T1 and the second one is T2. So at T1, at time T1 in the duration of reaction, okay, the T1 represents the concentration of reactant C1, okay, and when the reaction is proceeding, and at in time interval T2, the reaction is taking place and the reactant is going to have the concentration of C2. All right. So in order to find out the average rate, what exactly is the average rate? Is the rate, the change in the concentration of reactant divided by change in time. And it is going to have a negative sign. Why is it going to have a negative sign? I'll tell you in a moment. So over here, as we see, the T2, C2 for T2, concentration C2 for time T2, and concentration C1 for time T1. All right. So the change is going to be the difference of it. Okay. So the difference of concentration is C2 minus C1, and the difference of time is going to be T2 minus T1. All right. So why exactly is a negative sign given over here? Since we know that this is a reactant and the concentration of reactant is decreasing, that means the reactant is going to be consumed in the reaction. That is the reason we are writing a negative sign over here. Okay. And when mathematically, when we solve it, so at a given time, for example, at T2, the concentration of reactant is going to be smaller than C1, right? So mathematically, when we solve, since the concentration of C2 is going to be smaller than C1, why? Because when the reaction is taking place, when the reaction starts, the concentration of reactant is going to be high, right? But as the time is going to pass, the reactant's concentration is going to decrease, right? So that is why C2 is going to have a lesser concentration than C1. So when we solve it, it is going to come out as negative. C2 minus C1 is going to come out as negative. So the negative from the bracket and the negative outside is going to make it overall positive. So rate of reaction is going to be positive value. Okay. But the negative is there to show the consumption of reactants. Similarly, over here, let's talk about instantaneous rate. Okay. What exactly is instantaneous rate? Okay, so you might have seen in a moving vehicle like bike, a car, etc. You might have seen on the speedometer, the speed of the travel changes. The speed of the bike or the speed of the car changes rapidly. For sometimes it is 42 kilometer per hour. Sometimes it is kilometer per hour. When there's traffic, then it comes to zero as well, right? So that is basically the speed at that particular moment. Right. So over here also in the reactions, the rate of reaction at that particular moment, at a particular moment, we are going to call it as instantaneous rate. Okay. So the change at this particular moment with respect to at that particular time is basically the instantaneous rate. And this is also going to have a negative value. Okay. Which is going to be mathematically represented by negative of slope. Okay, so the tangent is formed over here and its value is going to be equal to the slope. All right. So yes, this was about the average rate and instantaneous rate. Now let's talk about the average rate and instantaneous rate of products. Okay. So why this products graph has a increasing fashion, right? Why is it increasing? Because as the reaction proceeds, the reactants are getting consumed, right? But the products are getting formed. So initially, when the reaction didn't start at time zero, there was no product, right? But as the reaction started, the concentration of product increases. Okay, so as the time increases, the concentration of the product also increases. So that is why the graph is having a increasing value and increasing fashion. All right. And similarly, over here also, we are going to find out the average rate, which is delta P divided by delta T. So we are taking two instance T1, that at its time T1, we are going to have concentration as C1, and for time T2, we are going to have the concentration as C2. Over here, you can see there is no negative sign, right? Why? Because it is not getting consumed, it is getting produced. That is why it is not going to have any negative sign. Rather, it's going to have a positive sign, which we are not going to write it, right? Because there is no point writing a positive sign over here because it is basically going to be same. So this is T1 and this is T2, and you may look closely. So if you look closely over here, since it is C2 minus C1 and T2 minus T1 over here. So for T2, the concentration is C2, and for T1, the concentration is C1. So the value of concentration over here is higher, that is at the time T2, the value of concentration C2 is higher than the C1 over here, because at T1 the reaction only started, it is in the beginning phase, so the amount of product produced, that is C1, is less, but as the reaction proceeded, more amount of product was formed. Hence at C2, at T2 we had a higher amount. So when we see C2 is higher and C1 is lower, so C2 minus C1 is eventually going to be positive only. So the overall rate is going to be positive. All right. So C2 minus C1 divided by T2 minus T1 is going to be our average rate. Now let's talk about the instantaneous rate. Similarly, like the previous one, we are going to find out the rate at this particular instant. So the change in the concentration of product at that particular instant is going to be equal to the instantaneous rate. All right. So I hope this was clear to you for the rate of reaction of the products and reactants. Now, over here, we are going to look at the factors affecting reaction rate. All right. So the first one is the temperature. Okay. So if you think about it, and if we increase the temperature, okay. So let's say you have a mixture of sugar and water, okay, and you are mixing it. So if you increase the temperature, that is, if you boil the water, the mixture is going to be formed very easily, right? The sugar is going to get dissolved very easily. So when the temperature is increased, the reaction rate also increases, right? So when the temperature, similarly vice versa, when the temperature decreases, that happened in the case of enzymes, right? We saw that in the case of enzymes, when the temperature decreased, the reaction rate also decreased, right? So when the temperature decreased, the reaction rate also decreased. So this is having a direct relationship with the reaction rate. Okay. So second one is concentration. So as we increase the concentration, okay, as we increase the concentration, the rate of reaction is also going to increase. Okay, because we are supplying a lot amount of concentration, so it is going to react very easily and is going to have a lot of molecules to get started with the reaction, right? So now the surface area. if we increase the surface area. Surface area is basically, if you imagine a wood, imagine a block of wood, okay, a small block of wood, and imagine a sponge of that same size, which is going to have effectively a higher surface area. The sponge, okay, because the sponge is going to have, let me draw you a sponge over here. So basically, wood and the sponge of this size, and the sponge is going to have these small holes, isn't it? So when the small holes are there, this is effectively increasing the surface area of the sponge, right? So for any reaction, when the surface area increases, okay, when the surface area increases of the of the surface on which the reaction is getting proceeded, okay, so it is going to have a lot of sites for the reaction. All right, so the surface area increases, hence the reaction rate also increases. All right, so now for pressure, when the pressure is increasing, for particularly for gases, okay, the gases are dealt in terms of pressure, and the liquids are dealt in terms of concentration. Okay, so as we increase the pressure, similarly, when we increase the pressure, it is going to increase the rate of reaction. Why? Because there's going to be a lot of pressure on the gases, and there are going to be more collisions because of the increase in pressure, and they are going to undergo the reaction much faster. Okay, so when we increase the pressure, the reaction rate also increases. When we decrease the pressure, the reaction rate decreases. Okay, and the catalyst as well. Okay, for the catalyst, so catalysts are basically of two types. So some type of catalyst increases the rate of reaction, some type of catalyst decreases the rate of reaction. Okay, so when we want a product, okay, for example, when we are dealing with a reaction which is having very fast reaction rate, okay, and that is the reason we are, and because of that, because of the high reaction rate, we are not getting the desired product. So what we will do is we will use such a catalyst which is going to decrease the rate of reaction of that particular reaction. Okay, so we are going to put that particular catalyst. And for sometimes when the reaction rate is very slow, so we need to increase our output. So for that, what we need to do is we need to reduce the duration of reaction. Okay. So for that, what are we going to do? We are going to use such a catalyst that is going to decrease the duration and give us the desired product immediately or very fast. Okay. So that is how these are the factors which are going to affect the reaction rate. And this was the last slide for my demo. I hope you understood what I taught. Okay. And I hope my teaching style is going to please everyone and the students, because I try to keep the session engaging as well. But since it is a demo, so it is only a one way. I am only speaking and there's nobody there. But my teaching methodology is basically teaching in such a way that it is going to engage the student, and I ask several questions during my session. When I take the session, I ask several questions. So it is basically inquiry based learning and a student centric approach, because I am not just focusing on giving my lecture and just going away. I am always focusing on whether the student understood or not. Okay, that is always my priority, because if I'm not able to convey the knowledge which is required by him or her, then there's no point for me teaching the subject or teaching the topic to him, right? So, yeah, this was my demo. Thank you so much for listening to my demo. And yep, I hope to hear back from you. Thank you so much. Bye bye.